I'm Emanuele Sobacchi. I'm a postdoc at Columbia University. In this talk, I'm going to discuss self-modulation of fast radio bursts. This plot shows several bursts from the repeating FRB 121102, and one can observe a frequency modulation with a large, of the order of a few hundred megahertz bandwidth, and several sub-bursts with short duration, meaning 0.5 to 1 milliseconds. And the question that I'm going to address is what is producing this time frequency structure. I'm arguing that the time frequency structure is due to nonlinear propagation effects. An important point is that the propagation of electromagnetic wave in a plasma becomes nonlinear where the velocity of the electron becomes relativistic. And in FRBs, this happens at close to the source at distances closer than 10 to 14 centimeters. Self-modulation is a classical nonlinear propagation effect, which is extensively studied in laser plasma interaction. And what happens is that self-modulation breaks the burst into pancakes, like this. And one finds that in electron ion plasmas with a density of 10 to the 2 centimeter per centimeter cube, self-modulation may develop at relatively large radii, meaning radii smaller than a critical radius of 0.1 parsecs. If the burst interacts with the plasma slab closer than the critical radius of 0.1 parsec that I was showing before, what happens is that the transverse size of the pancakes is smaller than the Fresnel scale. So one observes the superposition, the interference pattern of a large number of pancakes. And it turns out that the frequency modulation of bandwidth, 1 over the scattering time, is a fraction of a gigahertz. On the other hand, if the burst interacts with the plasma slab at a distance comparable to the critical radius of 0.1 parsecs, the transverse size of the pancakes is comparable to the Fresnel scale, so the time structure produced by self-modulation survives, and one observes sub-bursts. The observer sees sub-bursts with the duration equal to the longitudinal wavelength of the pancakes divided by the speed of light. This is typically of the order of several microseconds. So finally, these are my conclusions. I argue that self-modulation in electron-ion plasmas can explain frequency modulation with sub-gigahertz bandwidth and sub-bursts of tens of microseconds. And the same effects may also develop in electron-positron plasmas, such as in magnetar winds, and this is a paper in preparation.